Hi guys, this is NJ. Today I am going to talk about one of my sandbox for visualization, particularly using JS API, which is one of the product from Esri. So the reason I picked the JS API is because which is like very powerful API, and also it's free, as compared to the other Google Maps and maybe Mapbox. But anyhow, so JS API is a very powerful, and for those who are interested in developing your own app for whatever reason, like the urban designer or landscape designer or architectural designer, they can frequently need to understand what's going on in the special context in urban area. So in this case, mapping is really important. So the reason I'm sharing this boilerplate code is for those to help to create their own app or like research or some the insightful visualization for public or things like that. Yeah. So this is my GitHub. You guys can download by clicking here. So if you're familiar with GitHub, I actually use the GitHub desktop, so clone it, then you can start it, okay? Also, the other additional information is, since we are using the JS API, so actually there's a very nice documentation, so you can search like ArcGIS JS API TypeScript starter. So we're gonna use the TypeScript, by the way. Click it. It has a nice documentation here. So for those who are interested in what's going on behind the scenes, so I'm highly recommend to visit this website. Also, we have here the demo and boilerplate code. So this is the JS API resources and 4.x and TypeScript. So actually what I did is, I cannot remember, but probably I poked this Webpack version and a little tweak. And then apply some architecture, some pipeline for those who are, not have strong, background about the pipeline and TypeScript and things like that. Anyhow, I will describe it later in detail. So this is my GitHub desktop, and click right button, Visual Studio Code. So by using GitHub desktop, I open my source code. Maybe, okay, let me remove this Windows. So maybe if you guys open the code in the first place, we can see this kind of very simple window. By the way, I highly recommend you use Visual Studio Code. Since we are using TypeScript, the Visual Studio Code is quite good at for the intelligence feature and so on and so forth. So now we need to open the console. So let's go to View and Terminal, and automatically we can open the terminal here. So first of all, we need to install all the dependency library. So I'm gonna type in like npm install, press enter. And if your laptop has no node package manager, so we need to install this manager first. So let's Google it. npm install npm install for Windows or Mac, whatever your machine. It depends on your computer. So here's a link. So I actually installed it. So if you guys have some error by doing this, and then we need to install the node packaging manager first before starting. Okay. Okay. It takes a little time. Great. Once we did it, and then you need to type in npm start. So if you type the npm start, and it automatically compile and build, and then open web browser, and then just like this. it's gonna show some result on the browser. It takes time. Okay, here we go. So we have a base map here, and then we have some point visualization with animation here. Yeah, I mean, these are all about the boilerplate code where you can start building your own app or visualization platform. So yeah, I'm going to describe what's going on behind the scene, particularly for the pipeline that actually you don't need to understand, but good to know, right? So yeah, let's get started. So this is HTML file, so that always execute when you open the browser. And then this is the sort of entry point. The app gonna be execute this file first. Okay. Since we are using the JS API base map, so we need to import here a base map and map view here. So now we create the instance from two class, and then we need to pass these two instance to this customized class. Okay, start. So actually, all code happening from this point. Yeah. So we have particularly. We have a core folder and the data folder and the renderer folder. This is sort of folder structure to understand the pipeline. So let's visit the core first. Since the core library provides us with some of a playground and then resolve all the interaction and events stuff. So you don't need to worry about it because I already resolved it. So, but as I said, it's good to know, right? So here we have an old core library, right? So yeah. So let me increase the size of the screen a little bit. Okay. So we have a custom canvas because we want to visualizing our own custom data on top of JSAPI API. So since we are using the browser, so the browser nicely give us Canvas API, which is low level API just like WebGL, but it's always easier than WebGL stuff actually. So we're gonna build a Canvas as a custom renderer, and then at the same time we need a projection since we are using the JS API base map. So we need to frequently convert screen position to map position, and the other way around. So in this case, we need a projection. Yeah. And also we have a renderer here, which is like a custom renderer. Yeah. So actually the renderer is the place where you build your own code, whatever logic or visualization, whatever stuff. We're gonna visit later once we understand the core stuff. Okay. And also we resolve the older event. Basically, this is the sort of the place where we bind the core library to our renderer. So yeah, it's nothing special actually. So let's go to the core here. I create some of a simple namespace. And then the first one is the ArcGIS. Yeah. This is a sort of a class to help us to bind some feature with JS API base map. So maybe this is too deep, but I think eventually you guys need to understand to build the right app or product here. So for example, you don't need to worry about it, but this is more about not mouse, event basically. So let me open this map. So if you zoom and out or pan or changing your size of a browser like this, all the event is fired this moment basically. So what we need to do is binding some functions in that scope. So for example, when you resize your browser, the map will catch this event and then cascade this let's say event or moment to designate function in that scope, right? So what I'm trying to say is whenever you resize, we need to know, oh, this is resized, so we need to do something, right, accordingly. So because since we are using the custom canvas, we need to also resize the canvas size, right? That's how I put it. So, I mean, this kind of a boilerplate code to help you to append some feature, to map events. For those who need more information, again, we need to visit the JS API here. So let's say JS API map view event, for example. So, for example, you can type Control F, watch here. So in this document, it shows us, how we append the function when animation. Yeah, let's say. So the map view has an animation function. When the animation is triggered, we can cascade this event to this designate, the function inside of this scope. There are a lot of like an event listener here. So let me check the extent. Yeah, extend is meaning that this like a left top corner and right bottom corner, when they changed, we receive some event from the map view. Yeah, maybe it's too deep. Anyhow, so this is the canvas. So on top of the base map, as I said, we wanted to create our own custom canvas here. So this is nothing special, just create the new canvas and then append this canvas to the right DOM, And then we have initialize phase here, just like other real-time graphics like WebGen and OpenGL. And then the draw function is executed, let's say 60 times or 30 times per second. This depends on your machine. Yeah. Since we are using the real-time graphics, we wanna just like clear the canvas before we render. Actually, in the renderer phase, as I said, the renderer, how can I say? Okay, try to visit the class and then do render their own job. So we will visit here later. So don't worry about it right now. So anyhow, this is what the canvas does. Okay. It's nothing special, just like a very same as the other canvas implementation on the HTML, 5. On the browser, let's say. And then we have a event in action, which is really important, right? Because we use this map view like click and dragging and the mouse in action. So actually mouse in action can be divided by multiple distinctive phase, like mouse down, mouse up, and mouse drag and double click and pan and things like that. So I'm trying to take advantage of the pre-built event from the map view. So we can simply bind our own the mouse event function for each event. So some particular things that I can share with you guys is I actually create the custom mouse event data class. So what it does is basically parse the data from the JS API and then reprocess the data that we're gonna use throughout this app. Okay, it's nothing special. And yeah. And then projection. Yeah, projection is really important since we are working on two different coordinate systems. The one is the screen coordinate system. Let's say this coordinate system starting from 0 and 0 to whatever x and to whatever y. And also at the same time, we have the geographical position, let's say map view. Yeah. So that we are able to attach this point when you zoom and out and pan, whatever changing your map view. So this is really important. So this is very simple, to map, to map. Let's say we need like the X and Y screen coordinate system, probably like 300, 500, things like that. And using this special function, we are able to get the latitude and longitude, which is actually geographical position. Yeah. Vice versa, we have a latitude and longitude, then we want to reproject in order to get the screen position, right? So then in this case, we're going to use this function. So these are pre-built class as a backbone or like pipeline that you guys don't need to worry about right now because I already resolved it. So maybe later, if you get familiar with this code base, and then if your app is getting increased and much more complicated, then you can probably revisit and optimize this code later. Okay. Anyhow, so data is just data. Data is like a two-dimensional data. In this case, the inside of the list, it has the other list, the X and Y, Z. Yeah, actually I download this zip code data from web. I cannot remember, but it's easy to find by Googling. Okay. So yeah, it's nothing special. And the renderer. So actually the renderer is really important place where you build your own code, own algorithm, own logics, whatever reason. Yeah. So here, here the renderer, we have two different renderer. It's just examples to describe, what's going on. So we can visit the first one, renderer here. So for example, maybe this is good practice, yeah, for you guys. So basically, you can switch like this, right? In this case, we're gonna use the first renderer here. In this case, we can use the second example here, just like that. We can switch. So later, we can just build your own application here, whatever research or you aim to build this app. So let me remove it. So let's visit the first example, let's say. So we have a mouse move and mouse press. Later we can append like public mouse drag, whatever stuff. You can build your own custom function here. So anyhow, you need to save here. So what it does is, this is just the event listener that bind with this core library. So you don't need to worry about this one for now. And we have a start, meaning that it's gonna be execute one time before initialize the app. Okay. This is the renderer. Renderer meaning that we need to execute this one at least like 60 times or 30 times per second. Actually, these two functions are triggered by this Canvas core library. So I already resolved it. You don't need to worry about. Just focusing on this class. Yeah. So we can see the result actually. Save. Everything is gonna be saved. And then once you save it, it automatically reflects the change. Yeah. What's wrong? It's not gonna be happen. Oh. That's why. Yeah, the first example. This is my bad. Okay, great. Yeah, we have nice point grid with animation. So, okay, the renderer here. When they initialize, this start function gonna be executed. And we have a 10 time along the X and Y, and we have this kind of offset to create the endpoint that we will visit later. And then we push this information to that array, this pointer array. And then in the render time, we visit individual entity inside of this array and then just render it. Nothing special. Yeah. So that we are able to get this kind of oscillating animation point grid. Let's say, let me change something like, I don't know, maybe 5 and 20. Yeah, we have like a 5 and 10 grid system here. Let me rearrange the window a little bit. Okay. Okay, here you go. Oops. Yep. Yeah. Also, whenever you click it, you can, see, you can populate the point, right? So here we go. Mouse print will receive the screen position, X and Y. Using the screen position, we build this class, and then the classes actually give us a instance, and then we simply push this instance to that array so that the renderer take care of the rendering for that, the appended, the added point here. Yeah, and also Control-Shift+I on keyboard. As you can see, whenever you move your mouse, we see the screen position here because I simply put this console here. Okay. Here, sorry. This is happening when you press the mouse, and this is happening whenever you move your mouse here. Yeah. So these are pretty much about it. Let me jump to the next example. Yeah. We need to change this import. So now, since I changed this import, the class, we're gonna execute this second example. The second example is nothing special compared to the first example, but only change is we visualize this US zip code data here with the oscillation. Yeah. So here, nothing special. We have the event here, and then start, and then render. Render is the same as before, but start, it has a little bit different. Previously, we create a two-dimensional grid, and here, what it does is we try to access this data here, and then loop through all the data. Loop through all the data by 5, and then since the USGIP provides us with latitude and longitude, which is a geocoordinate system, we need to project, right, this geographical position to the screen position. So SP means screen position. With this screen position, we actually create the instance from this class. Once we create the instance, we simply push this instance to this array so that the renderer take care of the additional entity. This is nothing special, right? So let's jump to endpoint class. Yeah, this is the endpoint inherent from the end graphic space. So if you guys interested in, just press Ctrl and Shift, and then you can see more just like a simple OP pattern. It's nothing special. The inherent, sorry. I'm sorry. Oops. Okay. Yeah. The endpoint is inherent from the end geometry base. For those who wanted to build your own much more complex geometry, so you can more create some rule or pattern to control the complexity. So this is all about controlling and managing the code system and complexity. So anyhow, we have a X and Y here, which is screen position, and then with this position we create the A instance from the vector, which is I built for the custom class. So right now, okay, let's jump to this vector. This vector is nothing special. It's very common implementation of a vector. So you guys can tweak or add based on your purpose. Anyhow, so with this vector, actually we have a like a x and y coordinate system, I mean information. After that, we need to project this screen space to map space here. So this vector probably like a longitude and longitude, right? Because the one vector class not probably must have a two position. One is the screen, the other one is the geographical position here, let's say, so that we are able to maintain like a zoom in, zoom out or pan. As you can see, the point is actually attached to the map, right? So this is because whenever you create your own like event, I mean fire the event, the point is to project and reproject to update the vector so that we are able to see the animation on top of a map. So this is all happening inside of this function, okay? And these are help function for the projection, so you need to worry about right now. And then the render is important stuff. Yeah, every time you execute, we need to visit here and then do individual lines, okay? The first one is the projection. So actually this is not that good practice because, you know, even if you didn't pan or zoom in and out, it always tries to update the geographical system. I mean, let's say the screen position based on the geographical position. But for reason I'm just put it. Yeah. So, I mean, actually in the good practice is like that. If whatever the screen is pan or let's say zoom, then do this, meaning that you need to create a special function to monitor whenever whenever map view is zoom or pan, then we can execute this line conditionally. Okay, so I'm just gonna leave this one to you guys. You guys can build it. Okay, it's a homework. So so we have a time here, but the time has a little bit different. I actually applied some of our offset so that we are able to see, you know, irregular oscillating animation here. So this is just like nothing special, just like an offset for timer. So with this timer, we get some value. So I'm gonna reflect this value as the radius of this circle. Yeah, so that we are able to see this kind of oscillating animation. And this is actually nothing special. I just follow the documentation of HTMLCanvas. So for those who are interested in further, you know, developing your own drawing or graphics for the visualization or whatever data implementation, I mean the visualization. So you need to search like HTML Canvas API here. Click it. Yeah. So there's a thousands of documentation and material and examples out there to use Canvas API to draw like rectangle, circle, line, or a Bezier curve and things like that. So I'm just, you know, what I did is just follow the API in order to draw our own data on the map. Okay. So yeah, I think this is very rough. Or refresh. Yeah. Okay, so I think this is a very rough generic introduction of my Sandbox that you guys can freely tweak and use for your data visualization with map. I think I'm done. So if you guys have any question regarding this Sandbox, please leave a comment and we'll see. And I mean, I don't know, maybe later if I have free time, then I can create more examples to you guys on top of this, the Sandbox or base code. So yeah, thank you for watching this tutorial, and See you guys again. Bye.